Welcome to another episode here at Deep Mountain Security. Today we're going to be talking about Wireshark and how to sniff for traffic on your network. So I've got Kali Linux open up here. You can get Wireshark on Windows, but because it's already installed and built into Kali, I'm just going to demonstrate it in here. It's got pretty much the same functionality either way, so let's go ahead and open it up. And it's going to be under the Sniffing and Spoofing tab, and we're going to go ahead and open up Wireshark. Now, when Wireshark opens up, don't worry about this. This always happens when you're in just opening it up straight without any configuration in Kali. You're going to have a couple different items right here. You're going to see that we can capture stuff using a filter that's got some fairly complex in-depth analysis and tools that we can use to analyze traffic. So what I want to analyze here is Ether0. You can see here's my computer's IP address and MAC address. This is the NIC that or the network interface card that allows me to get out to the internet. So we're going to go ahead and start capturing traffic on that NIC. Now you're going to see nothing's really happening right now, but that's also because we're not getting out. So if we go overhead and open up Firefox, all right, so you're going to notice we've already generated some traffic here. And there's a couple of different things that it's opening up. We're not going to worry about too much of this right now. So let's go back over to Firefox, and I'm just going to show you what you can do with sniffing a network. Now, if you watched my tutorial on Burp Suite that I uploaded yesterday, you might already know that there's tools that you can use to completely capture and modify packets. This doesn't allow you to modify the packets before sending it on, but it will allow you to capture that. So included, if you manage to capture unencrypted credentials, then you can use those credentials or discover them and figure out what they are. So I'm going to visit a site that doesn't really have HTTPS, so it's running on basic, pretty much just a regular website running on port 80. I'm going to visit Instructables.com. This is a kind of a fun how-to website where you can make all kinds of stuff, but that's besides the point. So you'll notice it's www. We don't have an HTTPS there. If I hover over it, it says HTTP, so that's exactly what we want. Now, if we go back down, scroll down to the bottom of our traffic here, you'll notice that we've kind of got a couple of different colors and some different things that could be potentially interesting. However, we might not know what we can do with all this. So we can start looking and analyzing the packets themselves. So I click on one, it's going to display the data for it down here. So this is the data. These are the actual bytes in hex. And then over here is the actual data converted to ASCII. And you'll notice that all this right here is encrypted. So we're not going to worry about the encrypted stuff. We're going to go see if we can find maybe some non-encrypted traffic here. And we can just scroll until we find something that we think looks interesting. All right, we've already got some different things here. www.autodesk.com, Akamai, and a couple of other things. Autodesk, so it turns out actually Instructables is actually owned by Autodesk. So it makes sense that that's in there. So let's see here. Here we go. So here's a little bit more information in this packet. There's some encrypted content, and then there's some non-encrypted content. So you can see, we can kind of see the packets, and this isn't, there's more ways than this to see the packet, but we're just going to stick with this for now to keep things short and sweet and to the point. So you can also see, we can filter by a couple different things here, so we can see the different protocols that are being used. This is really nice. You can see source and destination. Because we're only capturing traffic on my machine, instead of using something like a promiscuous NIC, which allows you to see all the traffic on a network, then we could see all the traffic on the network if we had a NIC like that. But since we don't, and we're only viewing the traffic coming and going from this machine, you'll notice that there's always this machine in either one side or the other of either the source or the destination of this particular packet. So then there's a couple different protocols over here. The lengths will vary, depending on the size. So some of them are longer than others. And then we've got some different protocols like TCP and whatnot, but we're mostly interested in HTTP right now, as that seems to be what's going through. Here we've got some DNS queries as it tries to gather information on sites. And if you scroll all the way to the bottom and manage to keep scrolling, then you can actually cause something, in which case it'll default. So you notice as more data comes in, it shows up on the bottom. So we can sit here and literally watch the traffic come through without having to scroll back and forth, which can be nice if you're looking for something in particular and know what you're looking for. However, we don't necessarily. So let's go ahead and try filtering by some information. So let's try HTTP, and you'll notice that all of a sudden I've got a bunch of different kinds of traffic. Either you're having an HTTP in the protocol, so it's actually an HTTP protocol, or the response contains HTTP information. So you notice we can just go right through here and just look at nothing but the HTTP traffic. So this will get rid of things like DNS queries and other ambiguous traffic that we don't really want to view right now. Some of this will have a little bit more information on the info part of it as to whether or not it's a request or a response. We can also kind of make that out if via the source and destination, for example. Just looking at the source and destination of this, I'd say this is a response, but this one's probably a request just because we're sending something out and this one we're receiving something. All right, so from here, oops. Now we've got binary. I clicked on that. We can go back to hexadecimal. So you can see it as binary if you want to, or you could change this up to different encodings as well. However you really want to do it. Anyways, fine. But so we can sit here and we can kind of look at some of the different things that are flowing through. And this is useful if you're trying to capture traffic, or you just want to know what your computer is doing when it talks to other devices. For example, if you're running a secure environment and you don't want specific types of traffic or specific addresses to be used, or you want something more like a if you want a blacklist or a whitelist or something similar, then you can go into here and you can filter what you're seeing and kind of dig down and capture normal traffic. And then you can take that capture and you can actually analyze it at a later date. So if I was to stop this capture right now, then I could go down and I could actually save this entire capture, all the data in it, not just what I'm filtering out here, although you can continue to filter if you want. And you can save that to a specific file that you can later reopen the session in a Wireshark application. Can be on another machine, doesn't really matter, for further analysis and trying to figure out what in the world's going on and all these things. I'm just going to see if we can maybe find something interesting going on in all this stuff. So in this data, we're going to have things like cookies and other little bits of data that might be important to certain things. Looks like we've got some data right here. Not really 100% sure what that's encoded with right off the top of my head. Somewhere in another packet, it might specify how it's being encoded. If that was a basic authorization, I'd know it's base 64, but it's not. But anyways, you get the idea. You can go ahead and you can kind of look through some of this stuff and just kind of have fun with trying to figure out what traffic is normal. And after you discover what traffic is normal, then you'll be able to use that for a further in-depth analysis of discovering what traffic is abnormal, what traffic you don't want on your network. And once again, this is really important especially for encrypted not encrypted, but secure networks. So for example, if you're doing PCI DSS compliance, then this could be a useful tool to use to analyze the traffic on your secure endpoints, to make sure that they're not sending traffic to places that should not be receiving traffic. So it can be useful to kind of track down and see who's talking to what and how it's going through, and if there's any malicious traffic or if it's talking to something that you have not authorized, then this can be really useful. So I'm just going to clear our filter here, and you can see there's just all kinds of data in here. So maybe I just wanted to see DNS queries. We can do the same thing. We can put DNS up here, and maybe it wants a lowercase. And you'll notice now we've got all our DNS protocols. And this is mostly queries going out and a response coming back. So you can actually see here in the response, we've actually got the actual DNS record here. So there's, so for example, there's an A record. We've got a CNAME record over here, quadruple A record. So you can see a couple of different records here for different things. And so we're literally, when DNS is going out and capturing or requesting information on stuff, then it's literally getting the DNS record back, and then our computer can use it to redirect it to an IP address. Since we all know that computers don't actually use names to get to servers, they actually use IP addresses. Names are just useful for us to remember how to get to these IP addresses that no one wants to memorize. All right, so let's go ahead and clear that filter. So a little bit on filtering, on how to save your stuff. We'll actually save it here in a second. So there's a whole lot more tools here, and you can see you can even sniff Bluetooth traffic and wireless. It'll be a lot harder to sniff wireless traffic after WPA3 is implemented. That came out a couple days ago. I mentioned that, I believe, in the video I did, I think it was 2 days ago. And anyways, because WPA3 encrypts all the traffic between your device and the access point, no one else can decrypt your traffic. There's different telephony calls and stuff like that you can use for extracting data, and just all kinds of different tools that you can use to analyze stuff, filter things, drill down, and really get to know the traffic either on your network or on your device, depending on how you have your NIC set up and what you're looking at. So let's go through really quickly, just starting and stopping a capture. So if I stop a capture here, you can always click this to restart capturing packets, but let's go ahead and save this. I'm going to go save as, and then just right here, I have to save it on my desktop. We'll save this as capture. And then it's going to say, we can choose what kind of format we want. We can just have it as a pcap, so a TCP dump type of thing. pcap ng is Wireshark's default. There's a couple of other different protocols in here, and depending on what other instruments you plan on using to analyze this data, it might be useful to save it in a different format or import something into Wireshark and export it so you can use it in, say, another tool like Network Miner. If you want a video on that, by the way, let me know in the comments below. I think that'd be a really good tool to demonstrate. So let's go ahead and save this here and close out of Wireshark just to demonstrate that we're all done. All right, you can see my pcap ng file here. pcap stands for packet capture because that's literally what it is. And you can get individual packets into pcap files and other things. And when you have an IDS that's also looking and capturing packets, these are generally, or just .pcap or similar formats, generally what it's saving it as. So let's go ahead and open Wireshark back up now. And then we can, so you'll notice when I load Wireshark up again, it's going to take us back to our default screen. We're not currently on any interface, and we're not really doing anything. It'll let us open a previous capture, but let's just go ahead and open Ether0. So right here, we're starting a new capture, and as soon as I put some data on here, we'll see it go through. However, we can also go open. Besides clicking on that, open my capture here, and you'll notice here is all the traffic that I captured in that session. Now, there's also ways in Wireshark to extract the data. For example, you can extract it through, you can extract images, executable files, other types of files, and you can export that. I can do a video on that another day if you guys want me to. Let me know below in the comments. But this is pretty much your basic how to run Wireshark and how to sniff traffic and look at packets and packet sequences. As you can see, there's a lot of sequences here. So thank you so much for watching here at Deep Mountain Security. Don't forget to subscribe to our videos. You don't want to miss them because we're always doing updates on the latest and greatest in the security industry. Thanks so much for watching.